This deposits and contains numerous components for carrying out various experiments. In the following experiment, we will investigate the influence of the shape of the blades of a wind turbine. For the construction of the experiment, we first need the base unit, on which the individual modules can be plugged in. In addition, we require the wind turbine, which is attached to the module plate. Due to the unique connector system, the wind turbine is rotably mounted so that, for example, experiments about the dependence on wind direction. For this purpose, an angle scale is applied to the module plate. For the following experiment, we need a light-emitting diode, which acts as a consumer. Since we want to perform an experiment on wind energy, we do of course need a wind machine. For generating a laminar flow field, the wind machine is The wind direction is indicated by small arrows at the top of the wind machine. In order to complete the wind turbine, we of course need the rotor blades. Here we have a large number of various options. So we can choose, for example, between a flat blade profile and an optimized blade profile. The various hubs and caps let you vary the pitch angles of the rotor blades as well as the number of blades. In the construction of the rotor blades, initially we decide between the flat blade profile and an optimized blade profile. Whether we want to use 1, 2, 3 or 4 blades. Finally, we have to choose a specific pitch of the rotor blades. In each case, the blade pitch is printed on the back of the hubs. We'll now construct 25 degrees and an optimized blade profile. First of all, the rotor blades are inserted into the small recesses of the hub. Make sure that the rounded side is facing up. After all 3 rotor blades are adjusted, the cap can be placed easily and firmly. And now our wind rotor is finished. We have now collected all the related components for the experiment: the wind machine, the base unit, and our LED. Now we just need to attach the rotor blades of the wind turbine. The wind machine now needs electricity. This can be ensured, for example, by a conventional school PSU, power supply unit. After connecting the power supply, the wind machine is plugged into the base unit. Then we also plug the wind turbine with its module on the base unit. Care should be taken with the correct polarity. The LED is plugged in series to the wind turbine. The circuit is closed with simple cables. With this, our assembly is complete and the experiment can be started. We turn on the wind machine and observe what happens. First, the wind turbines begin to rotate and then the LED starts to light up. Turning off the wind machine again, the wind turbine is turning slower and the LED stops lighting up. Now we'll look at what happens when we use the flat blade profile instead of the optimized blade profile. The structure of the rotor blades is done in the same way as the optimized blade profile. Again, the rotor blades are easily attached to the wind turbine, which is applied to its module. We then observe what happens when we turn on the wind machine. The wind turbine starts to turn, but the LED does not light up. The turbine is significantly weaker with the flat blade profile than with the optimized blade profile. This is the reason why the LED is not lighting up with the flat blade profile. The experiment system includes, besides the used components, further elements to vary the wind turbine. The accompanying CD includes all the experiments for both students and teachers. In addition to the experiments with a conventional wind turbine, experiments can also be performed with a so-called Savonius rotor. The resistor operates as a simple consumer. With the capacitor, experiments on storing energy can be performed concerning IV characteristics. In addition, the experiment system is able to be expanded with qualitative consumers such as a horn, a motor module with coloured discs, and a light bulb. With the extension, the anemometer, it is possible to measure the wind velocity in the experiments. We hope you have fun experimenting.